Let's talk about the action potential. Often you will see this chart, this voltage versus time chart when talking about action potential. You can see we have a resting memory potential of negative 70 millivolts, a threshold of negative 50, and a peak of plus 30. First, we start off with nothing. It's a resting memory potential. However, we can start seeing that uh, once the dendrites carry current all the way down to the axon hillock, we can expect to see a depolarization, which we can depict right here as a little bump. If the current is enough to create that depolarization to reach that threshold, then we can expect to see sodium ions rush inside and thus begin an action potential. From here, we can see that this channel right here, it starts to open up. And so all of these sodium ions just start rushing inside. They make it their home. They're inside now. And we can expect to see this as a quick rise of depolarization all the way to the peak of 30 millivolts. However, from here, the sodium ion, it closes. And now this potassium channel, it opens. So then we can expect to see some potassium ions leaving the cell so that it is able to return back to a stage that it likes, the resting memory potential. However, though, this is called hyperpolarization. It goes all the way down, further negative than what its resting memory potential is. And then it's able to recover back through a process called repolarization, where repolarization is just the use of a sodium potassium pump that is able to spit out sodium, excess sodium, and then bring in potassium ions. It does this by doing 3 sodium ions out and 2 potassium ions in. And then we have reached back to our resting memory potential, and the action potential is able to begin again through the axon.